Good morning, everybody. This is Wednesday, October 12th. Well, it's almost the afternoon, but good morning. This is Ms. Johnston. I am currently at OFSA, but this is our pre-recording class. And yeah, so go ahead and grab lesson 2. We are going to be looking at this today, quadratic relations, vertex to standard form. If you don't have this page, please ask a supply teacher for it. If not, then you can print it off on the OneNote. Or grab a piece of paper and record some of these things on line paper. So today we're looking at, well, we're on Unit 3, which is more quadratics, but it's part 2. Today is day 2. This will be a video recording, which I'll have it posted right here. Looking into the future, we will be having our Unit 3 test on Wednesday, October 19th, and our parent-teacher interviews will also be on the 19th. Okay, so go ahead, have lesson 2 in front of you, and let's go ahead and try some of these things out. So to review, what is this? What equation is this? If you guessed a line, you're right. This is a linear function or a line. Most important function in grade 9 math. What about this one? Yeah, that's also a line, but this is what we call like standard form of a line. This would be like our, up above here would be our slope y-intercept. Right, the slope being m, the y-intercept being b. This is standard form like a, b, c. Therefore, what's this form? Do you remember? You can find your what point is the HK. Vertex form. Well, we again see the ABC, this is their standard form. But here, for both of these, we're looking at, these are both quadratics. This is our quadratic function. All right, so let's discover. So we're going to sketch the equation here, and then also use a table of values to sketch this equation. Okay, so we've done this before lots of times. Let's go ahead and sketch our vertex. What's our vertex here? 2, 1. So go over 2, up 1. What's our step pattern? You can tell by the number that's in front for A is just a 1, so it's 1, 3, 5. So we move over 1, up 1, over 1, up 3, and that should be good. If you want to do over 1, up 5, go for it. Over 1, up 1, over 1, up 3. And we have our graph of this equation. Y is equal to x minus 2 squared plus 1. We move to the right 1 and up 1. Or right 2 and up 1. All right, let's go ahead and look at this one. So we got x squared minus 4x plus 5. Here we're subbing in -1 and solving for y. Subbing in 0 and solving for y. So 0 squared is 0 minus 4 times 0 plus 5, that gives us 5. Right, let's go ahead and put 1 in for x. So wherever we see an x, we're going to put a 1. For the first one, we've got to square it. Minus 4 times 1 plus 5. Go ahead and put that in your calculator. So you have 1 squared minus 4 times 1 plus 5. You can use decimals as well if you like. So we got 2. This is 1 minus 4 is -3. Add 5, we get 2. Right? 2 squared minus 4 times 2 plus 5. What do we get there? Right? We get 1. What about y is equal to 3 squared minus 4 times 3 plus 5? Okay, here we get 9 minus 12 plus 5 is 2. And y is equal to 4 squared minus 4 times 4 plus 5. Well, this is going to be 4 squared minus 16 plus 5 is 5 as well. Okay, let's go graph these points. So we're going to go -1 up 10. So over 1 up 10. 0 to 5. Over 1 up 2. Over 2 up 1. Over 3 up 2. And over 4 up 5. Right, so we got this nice curve. What do you notice about these two graphs? Well, this one is like x squared minus 4x plus 5. What do you notice about these two? This one looks like a little longer right here. Would that be okay for this one if we moved over one up 1, 2, 3, 4? Yeah, I didn't do over one up 5, so if I did, maybe it'd be like a little bit. Hey, they're the same. They're the same. If you guess they're the same, that's awesome. Yeah, they're the same graph. But they have two different names. But their names are different. This is y equals x minus 2 all squared plus 1. And this is x squared minus 4x plus 5. But they're the same. They're the same graph. All right. Well, just like anybody's name, you can have like a name written as maybe like your nickname, and then a name maybe written out like the longer form, so not a nickname. So we can have names that don't really look similar, but they're identical. They mean the exact same person, or they mean the exact same graph here. So this is what we would have this is our vertex form. This would be the vertex form of this graph, and this is what we call standard form. Okay, standard form, we can see that we're using a table of values. Vertex form, you can use our vertex and our step pattern. All right, let's go ahead and expand some. Again, you can pause the video at any time and can take some time to record things. All right, so let's do some expanding. Here we're going to multiply -3 by 2. Right, so here we're multiplying everything by -3. So multiply the 2 by -3 and the 3 by -3. So we get -6, or well, what's happening here is -3 times 2x plus -3 times 3. So that -3 is being expanded to everything in the bracket. So it's being multiplied by the first term, that's a term, and multiplied by the second term. So the first term and the second term. So that just means we're going to get -6x minus 9. All right, so for this next one, it's telling us that there's 2 of them. Okay, so let's write them both out. There are 2 of them being multiplied by each other. Because if we had anything like squared, like 4 squared, this is just 4 times 4. Or if we had this squared, this is this times this. Do you remember how to expand something like this? Starts with F, and it goes O, and then an I, and then an L. FOIL. First, outside. Maybe I'll do another color. Inside, and last. So the first x gets multiplied by x times x, we get x squared. The x gets multiplied by the -2, so we get x times -2, that's -2x. The -2 gets multiplied by the x, that's -2x again. And the -2 times -2, that's +4. Then we can see that we can bring these two together because they're like terms. So we get x squared minus 4x plus 4 as our final answer. So -2 and -2 gives us -4. All right, let's go ahead and try this one. So for this one, we want to do the same thing. So we want to FOIL out the x plus 3's because there's 2 of them. So we're going to use FOIL to get this. So we have x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Right? We can put together these two common like terms just like beforehand where those are common in the brackets. But is that done? Is everything expanded? No, not yet, right? Everything has to be doubled with a subtraction sign. So that this 2x right here, or this -2 gets multiplied by the x squared, the 6x, and the 9. So we get -2x squared minus double this with a negative, and double this with a negative. There we go, -18. All right. Next, we're going to go from quadratic, these quadratic relations to standard form. So we want it like this. We want it ax squared plus bx plus c. We want it to look like A, B, C. So no H and K's anymore, right? These are all looking like H and K's. None of those, we're gonna make it into this really long form. So no more brackets. So we have x plus 6 times x plus 6. Go ahead and try that one out. X times x is x squared. X times 6 is 6x plus 6x right here, and plus 36. So we got x squared plus 12x plus 36. Right, for this next one, we're going to do the same thing as above again. Let's use FOIL first and then multiply everything by -2. Let's just keep the -2 on its own, get the trinomial or the 3 terms in the middle, and then multiply them all by -2. Here we get a positive 49 because -7 times -7. Again, press pause at any time. Here we get -14x plus 49. And we're going to double everything, right, with a minus sign. So -2x squared. 14 times 2. Those are both negatives, so they become a positive 28x. And then 49 times 2. One's a negative, one's a positive, so we know we're going to get a negative. It's almost 50, right? It's almost 50, but not quite, and there's 2 of them, so we get a 98. All right, last one. We're going to do the same thing, but this time we have a -8 on the end. So we're just going to leave the -8 alone, FOIL this through, multiply it all by 3, and then attach the 8 to it. Right, so we got x times x is x squared, -5x, subtract 5x plus 25, because it's 5 times 5. Leave that -8 by itself. So x squared minus 10x plus 25. Again, leave that -8 by itself. It's not going to touch the 25 because everything has to be multiplied by 3 first. So we get 30x plus 75. And then -8. Now we can finally put, where's the 8 going to go with? Who's that going to go with? Yeah, the 75. So 3x squared minus 30x. And what do we get there? A 60. Take away 5. And then 3 more, so 67. Alright, so we've got vertex form, which is y equals a, x subtract h squared plus k. That's what we were looking at all last unit. And here we're going to have this new function, and they want us to change it to standard form. Alright, so we've got y is equal to, again, we're going to write this out twice, x plus 2 minus 5. X times x is x squared. We don't need the brackets anymore because there's no number in front, so we could just multiply these through. If there's a number in front, we do need those brackets until we multiply that number in front. So this is just x squared plus 2x plus 2x. See how the middle term was always the same here? Because it's, there's 2 of them. Alright, so we've got x squared plus 4x minus 1. Okay. And then we're going to go graph this and see what it looks like. Right, so this is the graph, and we've got x squared plus 4x minus 1. So we can see here we have our graph. We could also graph the other vertex form. Right, so here's the other vertex form. We can see they're the same graph. We can also see that we get -1 for the y-intercept. Do you see a -1 here? Yeah, it's right here. Guess what? It's always your c value. It's always that last value within your form. This one is always going to be your y-intercept. So our y-intercept is 0, -1. Okay, so some key concepts. Is the same parabola? Yes, we just graphed it. Yes. So some key concepts are, if we have vertex form, you could change it to standard form, expand and simplify the vertex to write into a standard form. So here we know that this is the vertex and that the y-intercept is c. Go ahead and work on the homework, and we'll see you on Friday.